there are essentially two big families of technologies that you can consider when you're talking about resonators. There is the hybrid resonators that you can build essentially by putting external components together, and then there are fully integrated resonators that you can do by integrating everything on chip. Clearly, as I have already mentioned before, in general, the integrated resonators will have a lower quality factor than the hybrid ones. So the other part that you can see here is that I have a frequency scale on the very top, and you should not be reading this as an absolute measurement or absolute numbers, because these vary very widely for different technologies and different choices that one can make. But it should give you a first rough guess of which technology you should be thinking about, at least when you start talking about resonators. For example, if somebody asks you to design a filter at 100 gigahertz, it's very clear that you should not be considering lumped element resonators, while cavity resonators might actually be something much better to consider here. Now, there are also some filters which I'm not covering in this class, but I actually want to mention a few words about, and these are basically mechanical resonators or surface acoustic wave resonators, or even crystal resonators. So these are resonators that essentially the electromagnetic wave is first translated through a piezoelectric transducer from electromagnetic wave to an acoustic wave. And so the resonator itself is actually using acoustic waves. That's why we have micromechanical resonators or surface acoustic resonators or bulk acoustic resonators, like for example are the FBAR resonators. It turns out that mechanical resonators are actually amazingly high quality, and at the same time they're very, very small. So there's a whole family, which we'll try to cover a little bit later on, that basically relies on acoustic resonances. And that family has produced some of the best filters in the world. And in fact, our available filters today for cell phones are basically acoustic filters. So there are pros and cons, of course, to that technology as well. For example, it's very difficult to make these acoustic filters tunable. But for static filters, these acoustic filters or mechanical filters are actually superior to electrical filters. Now, also, those have some limitations. You can't push them very high in frequency. Today's cell phones are 1, 2, 3. Maybe we can push them to 6 gigahertz. There is some thought that you can go up to 10 gigahertz. But you start now pushing them to the new 5G bands, 30 gigahertz, 40 gigahertz, 60, 80, 100. And actually, it's almost impossible to make them work there. So for any 5G bands in the millimeter wave, it's really important to consider the electrical resonators. So thanks a lot, and we'll talk next time.